Hey everyone, welcome to Orb Creations, the show where I build an app, you get to see how I do it, and you get the source code in the description. Today we're building a tic-tac-toe app. This app will allow you and all your friends to play tic-tac-toe together. Our tic-tac-toe app is going to show a heading to indicate whose turn it is, as well as the game board. We'll need to store the current turn in a state variable, which we'll provide through context. We'll come back to flesh out the definition for this context later in the video. Timestamps are in the description. First, let's go look at the board component. The board in tic-tac-toe is a 3x3 grid that resembles a table, and we'll want to keep track of the entire board in our context to be able to check when the game is over or when a player has won. We'll store the board as a 3x3 array of X's and O's and map the array into a table. In each table cell, we'll want to render a square component that handles the functionality of detecting user clicks and displaying an X or O depending on the turn. The square component will take the XY position of the particular square as input, as well as a player prop that tells it which player has control of that square. For example, X's, O's, or neither player. We want each square to be a button. When the user clicks on the square, we'll execute a function called makeMove, which performs all the actions we need, like displaying the X or O and switching to the next player's turn. If the square has been filled, in other words, if the player prop is an X or an O and therefore not an empty string, we want to disable the button to prevent double clicks on the same square. Inside the button, we'll render a div element so we can apply styles to make the tic-tac-toe board appear as it should. We'll come back to style this in a bit, but since the style of the div depends entirely on whether it shows an X or an O, as well as what part of the board the div shows up on, we'll go create the game state logic first. The game state is going to be held in context, and it will represent some data that keeps track of whose turn it is to make a move, as well as the position of X's and O's on the board. The game state will also expose a function that allows the user to update the game state, for example, by clicking a square to make a move. Let's go ahead and create a context for this and initialize it to an empty default. We'll also export a hook for this context that allows us to access the data in the update handler in the child components. Now let's write the logic for the game. The first thing we need is a data model to represent the game board. Remember that we said this will be a 3x3 array that represents X's or O's depending on which player occupied that square, or an empty string if neither player has occupied that square. To initialize the board, then, we'll need to create a 3x3 array of empty strings. Next, we need to figure out whose turn it is to make a move. To do that, we'll need to know what the board currently looks like. In our current version of the game, X's always move first. So if there are an equal number of X's as there are O's on the board, then it must be X's turn. This also applies to the beginning of the game when there are no X's and no O's. So, we want to count the number of X's and O's on the whole board, so we'll initialize some counter variables to 0. For each row in the board, and then for each square in the row, we want to increment the variable that corresponds to the X or O that shows up. After we've counted up the X's and O's, we want to check whether the number of X's equals the number of O's, and then report that it is X's turn to move if so, and O's turn to move if not. Great. That's all the data we need for our tic-tac-toe game. Now we need to create an update function to allow the user to update the data representation of the board by making a move. For this, we'll create an update turn function that takes the XY position of the square to update, relative to the board, and updates the 3x3 board array. If the XY position of the updated square matches the JI position of the element in the array, we'll update the value of the player who is currently moving, which is held in the turn state variable. Otherwise, we'll keep the value at the position the same as it was before. Now, back in our square component, we can create our handler function that gets triggered when the user clicks to make a move. To do so, we need to pass the XY position of the square and the update turn function from our game state into our hooks. Inside our hook, all we need to do when the user makes a move is call the update turn handler with the XY position of the square. Then, we can return the handler and use it in our square component. We can also style the div to look more like a tic-tac-toe board and also to display X's and O's now that we have the game state that defines the logic for it. To start, the square should have borders depending on its XY position on the board. So we'll define a helper function to make that translation. The helper will take the XY position as input and return the CSS styles to draw the borders. Our CSS style can optionally add borders to all sides of the square. For example, the square in the middle of the board would have borders on all sides, whereas a square in one of the corners would only have a border on two of its sides. To begin, we'll initialize the object that holds the CSS styles. Then we'll set up 4 conditional actions to take, one for each possible side the border can appear on. In our grid, 0, 0 is the top left, and 3, 3 is the bottom right. So, if the value of x is greater than or equal to 1, meaning that the square is either on the right side or in the middle of the board, we'll create a left border. This would apply to all the squares on the right half of the board because they'll all have an x value greater than or equal to 1. Following the same logic, we can create similar conditional actions for each of the other border sides. Finally, we need to create the CSS for displaying an X or O on the square once it's been clicked. Remember that player is the prop that tells us whether the square should be filled with an X, an O, or neither. We'll use it to index our styles and then define a CSS class called X and a CSS class called O. We'll also create an inner CSS class to style the square more generally. For example, we want the square to show up with the full width and height of the table cell around it, as well as set its position to relative so that we can manipulate our X and O positions more easily. To create an O, we're going to render an after pseudo element with a black border and 50% border radius. Remember to set the content style on the pseudo element, otherwise it won't render. Then we'll want to set its position to absolute and use some positioning styles to center the O. Finally, we'll make its height and width 80% so that there's a little bit of space between the O and the actual boundaries of the square. For X's, we'll want to render 2 pseudo elements, before and after, and rotate them 45 degrees in opposite directions to create 2 crisscrossing lines that appear as an X on the screen. To do this, we first need to style both strokes in the X the same way, with a black background 5 pixels wide and positioned in the center of the square. Then, all we need to do is define a CSS transform to rotate them in opposite directions, and we'll have our X on the board. We're almost done. The only thing left to do is write the game logic to check whether a player has won or the game is drawn, and then reset the board. To make this check, we'll run a useEffect hook every time the board is updated. The hook will execute a helper function to check whether the board should be reset, and then reinitialize the board if so. All the magic happens inside this should reset board function. All of it. In tic-tac-toe, there are a few kinds of win conditions. You can win horizontally, vertically, or diagonally. We'll define a function to help check each win condition, put them in an array of functions, and then loop over that array to check each win condition. If one of them is true, then we'll report that the game is over. If none of them are true, which means if neither player has won, the game could still end in a draw. A drawn board in tic-tac-toe occurs when the board is entirely filled, so we'll loop through the entire board and check whether a blank square exists. If even a single blank square exists, then the game continues. For the win condition checkers, we want each checker function to take the game board as input and return a boolean which reflects whether that win condition was met or not. If any of the win conditions are met, the game ends. We'll also define a helper function called checker as a closure. The closure will be initialized with a base which can either be X or O. The base serves as the point of comparison for subsequent squares within that comparison set. For example, when comparing a row, the first square in the row will serve as the base, and subsequent squares will be compared against the base to check the win condition. Similarly, for columns and diagonals, one of the squares will serve as the base, and subsequent squares will be compared against the base. The first way to win tic-tac-toe is to connect 3 X's or 3 O's in a row. This checker will check whether some of the rows have identical values in every square. So we'll use the array.sum and array.every methods in JavaScript. For each row we iterate over, we want to instantiate the checker with the base as the first element. Then we want to iterate over the rest of the row and use the checker to evaluate whether each square has the same value as the base. If a row has 3 of the same values, this function will return true. Another way to win is to fill an entire column with 3 X's or 3 O's. To check for this case, we have to use a regular for loop because our game board array is set up in the opposite orientation. This function is otherwise very similar to the row checker, but instead of looping through rows and then columns, it loops through columns and then rows. A final way to win at tic-tac-toe is to fill one of the 2 diagonals. No matter which diagonal a player uses to win, the middle square in the board will be part of the diagonal. That means we can set the middle of the board as the base for comparison and then check to see if opposite corners match the middle square. And there you have it, a tic-tac-toe app. The app is currently hosted on Orb at tictactoe.orbapps.com. Link is in the description. All of the code that goes into this app is linked in the description. Be sure to check out these other videos on your screen right now. YouTube doesn't tell me ahead of time what they are, but I'm sure they're great. If you want to stay up to date on new apps we're building and coding tips and tricks, be sure to smash that subscribe button and follow us everywhere else. Until next time, remember, tic-tac-toe is meant to be a friendly game, because you always end up drawing in the end.